analysis from McKinsey, where basically they canvassed a variety of use cases across industries and looked at what was the incremental sort of value add. And what they found is that the sort of latest generation of techniques around deep learning, reinforcement learning, etc., on average had about a 62% uplift in value, which is really staggering. And obviously, there's a significant amount of investment that is therefore going into R&D around data science. And this will mean that millions of models will be produced over the next few years. And as obviously many of you will know, that any new technology that is created generally follows this kind of S-curve, where you have this kind of period of sort of steep technology adoption, and it kind of levels out at the top. What machine learning and AI is enabling is this kind of continuing acceleration from an S-curve to more of a sort of J-curve as more and more processes get automated, that really is extremely game-changing for all industries. So a lot of people focus on the role of the data scientist, and they obviously play a critical role. But I think what is often underappreciated is the importance of DevOps in deploying machine learning, and that's really kind of the main focus of this talk. Obviously, business users as well are finding the problems to solve, issuing budget, and influencing the business KPIs. But really, the two technical roles here need to kind of work in sync in order to put machine learning into production. And actually, the data science and the DevOps teams don't just do completely different things. So the data scientists are in charge of developing models, and data engineers, who are often closely connected, are creating the pipelines to feed that data into the data scientists. And they speak a completely different language to the DevOps team, who are actually responsible for productionizing those models and enabling them to actually run within your business applications. And what we find is there's often kind of like a siloed. These teams are often siloed, especially within larger organizations. They're not sitting next to each other. They're in different rooms, different departments, and this causes a very sort of poor feedback loop. And there's often quite a long delay between a data scientist creating a model and it actually being productionized. There's a third role which is seeing emerging now, and sort of a trend emerging around this concept of ML ops. And ML ops effectively is a kind of interdisciplinary skill set which combines an understanding of data science and DevOps, which is really hard to find. So what we're producing is, and what a lot of people in the industry are producing, are technologies that can enable data scientists to tackle more DevOps-related challenges and vice versa. So there are two broad workflows in data science. One of them is model development, and the other one is model serving. And this is quite a simplistic pipeline here. You have training, data cleaning at the top, moving through to feature engineering and building models. Once the model has been created, you have a kind of live pipeline which sometimes requires the data to be normalized, transformed, and the actual model to be served, which actually, when we run a model, the sort of technical word we often use for that is inference. So we're very focused on inference, not training. And as your company grows, your technical infrastructure should grow with it. So as you have like a very small team, that's handling the entire ML project, that works fine, in the kind of early stages. But as you grow, you start to have bottlenecks around things like version control and orchestration, because you have many different models that you need to test and deploy, not just have a very small set of models that kind of are okay for an R&D environment. So two key principles really are around reproducibility. So if you could go back in time and replay that model, will it deliver the same results or as close to as possible? And orchestration, so fast tracking these experiments. And the next piece, which is I think a really key part of ML ops and machine learning in general, which is is incredibly important, is to ensure that when you're developing models that they are deployed responsibly, and you have a good sort of code of ethics behind them. So what I'm sharing here is actually the 8 principles from the Institute for Ethical AI and Machine Learning, which is a group chaired by Alejandro Salcido, based in London. And these are the 8 principles that they've identified for responsible machine learning. So just quickly, human augmentation, so you have human in the loop, especially in the early days of R&D, to see and sense check what has been created. Bias evaluation, so if you have inherent biases in the data, that can feed its way into the output, which obviously has negative consequences and can reduce the time to deploying models. Explainability by design, so that not just in the models, but also in the UI that you're doing to show that you're producing to run those models. So maybe someone who's on customer support can explain to the customer why they, maybe a loan was declined. Proper reproducibility end to end. Having a displacement strategy, so what's going to happen when we produce an AI which has automated a whole team's worth of jobs. Having accuracy sort of analysis and ensuring that that doesn't sort of dip over time, and if it does, how we're going to resolve it. Trust beyond the user, and data risk awareness as well. So elements of security are obviously important there too. So the way they see it is a 4-phase strategy for rollout, and we're in the first phase still, which is basically understanding what are the principles for ML, ethical AI, and machine learning, and that should take about a year. I think we're pretty much getting close. Then understanding the processes that businesses need to run to practically implement this. And then only in about 2 to 4 years where you start to see proper standards emerge. People are talking about standards, but there's no across the board standards other than maybe see things that are inherited by GDPR, etc. And then regulation. So you can read more about this here. I'm closely connected to this group as well, and be speaking with them at their advisory board on the 19th. So I really appreciate feedback from people who are actively deploying machine learning within large enterprises, so that I can help inform that discussion. So to summarize, main challenges we're seeing around inefficiencies of building and maintaining ML infrastructure. It's very complex to build this stuff in-house. Skills gap between data science and DevOps, and compliance challenges and ethics challenges. So our focus at Seldom, just to summarize, it's not just about building models. There's a full end-to-end machine learning pipeline that people need to put in place. We focused on the later stage here of serving models, or optimizing them in production, and we plug into some of the leading open source stacks for machine learning, for machine learning pipelines and infrastructure, such as Queueflow, which came out of Google, and IBM Fabric for deep learning. So Seldom Core is an open source core product which supports models that have been built in any of the any programming language, and also any framework. So things like TensorFlow, which is obviously very popular. We can also support things like R models or H2O, and any inference engine. So Clive will talk a bit later about how we've built our inference engine at Seldom, but we also support other inference engines from NVIDIA, Intel, also TensorFlow serving, which are more optimized for particular frameworks or particular hardware. And we've designed Seldom in a way that you can really leverage all of these in one go. We also, within Seldom Core, focuses on deployment, the challenges that are around that, so auto-scaling being an example, having kind of a nice orderly process when it comes into actually updating your models in production, not just sort of crossing your fingers and hoping for the best, having things like canary tests where you can carve out a little bit of traffic and see if things work well, proper monitoring, optimization, not just of the model, but also the infrastructure, the latency, etc. Make it really easy to integrate into your business applications through APIs, message queues. We're even going beyond APIs actually at the moment for some use cases, using things like flat buffers, which are kind of directly connected into the memory. And management layer, a lot of that is, will be enabled through a new UI that we're building for the data science team to collaborate. And as you have better collaboration, we see there's better audit trails, better compliance. And a lot of these processes are underpinned by CI/CD, so tools like Jenkins, which on the continuous integration side, in this context of machine learning, is typically around model training. When the models have been trained, they get handed over for continuous deployment. Seldom is more on the continuous deployment side, but we play nice and work with all of the training tools that are producing those models. And we provide for our customers a setup which includes a CI/CD to hook into their training systems. Recommend checking out Queueflow. This is a big partner collaborator of ours. It's a project which emerged from Google. It has about 30 different collaborator orgs, including Intel, Red Hat, Cisco, and many more. They see the ML infrastructure as kind of the challenge they're facing or the problem they're solving is around providing a kind of scaffolding that enables people to piece together best of breed open source technologies, which is custom for their business. And they're approaching it that way and plugging in external projects rather than just making it a Google-only product. So we think we're doing the right thing, and I think the market is telling us that as well, also driven by the validation we've had from Google and IBM and our open source community. What we're seeing at the moment is a tremendous growth in active clusters. So week on week, we're seeing currently about over 20% growth in active clusters and over 30% growth in nodes, which translates to about a 20% week-on-week growth in nodes per cluster. So people are using those servers for more demanding workloads, more demanding inferencing workloads. So we're really excited about that. And the final point, which I won't go into big detail on right now, is our next product that we're working on at the moment. It's called Seldom Deploy. It provides a UI for managing Seldom core clusters. So multiple clusters could be in different clouds, data center, manage your hybrid cloud deployments. And key focus is around enabling collaboration between data science team members and compliance. So having that nice UI to show things like explainable, the output of explainable AI. So you can sign up for the beta by obviously speaking to anyone in the room, but you can also sign up here, any Seldomites in the room obviously. And final point, I highly recommend reading this book called Accelerate. It's actually not just machine learning focused, it's more DevOps in general, but I think you'd really like it because it's like it explains very clearly the intersection between DevOps and business sort of transformation, and how the two things go hand in hand. And the organizations that get this right are the ones that are like really leading the charge. So if you also have other execs or people that you need to kind of convince on this, who haven't got time to read it, I recommend sending this podcast from Andreessen Horowitz, which clearly explains this stuff in about just under an hour. So on that point, I'll hand over to me.
We have copies of slides.
Absolutely. Yeah. Yeah.